Welcome to a new video. In this video, let us see or let us discuss about inside the computer and internal organization of computers. So I choose this particular topic in connection with the previous two videos of 8051. So here you will come to know what exactly inside the computer will be there and what are the different important things which one has to remember while starting learning about a particular microprocessor or a microcontroller. So let us start with this first one, inside the computers. So inside the computer, what is there? So we already know that there will be a CPU, central processing unit will be there. So this CPU will be connected with two important blocks. So every processor or every controller will have three important units inside that. One is CPU, it is connected with two blocks. One is memory, both RAM and ROM, and the next one is I/O peripherals. So these I/O peripherals could be keyboard, monitor, printer, etc. So, and if you closely look at this diagram, whatever that I have drawn here, CPU is connected with two blocks, memory and I/O, with the help of two different buses. So in this first diagram, I have shown you only two different buses. There is one more bus that you will come to know in next few minutes. So this, the one which is in red in color, or the one which is on the top of these two blocks is called as address bus. Okay, and the one which is in the bottom, this is called as data bus. So every device, here there are devices like RAM, ROM, I/O peripherals, keyboard, monitor, printer, etc. So this every device needs to be recognized by the CPU. So CPU will recognize these devices with the help of address bus. It will assign, it will put some address into the address bus so that the decoding circuitry will find that particular device. So for example, I want to find out, or I want to read something or write something into these memory blocks. So first I have to put that address, which particular address location you want to read, which particular address location you want to write. So such information will be given to us by the CPU with the help of address bus. So the device need to be recognized by the CPU with the help of address bus, the address which is assigned by the CPU to each devices. And here one important point is, the addresses are unique. No two devices will have same address. Okay, so addresses are unique. Now coming to the data bus. So data bus will be helping us to move the data from one place to other place inside the computers. It is just like a transportation, like a bus which is moving the people from one place to another place. So data bus is helping us to move the data from one memory location into another memory location, or from one device into another device, from one place to another place inside the computer. So if you look at this, what is a bus? Bus means it is a strip of wires. So here I told you about address bus and data bus. So what is a bus? Bus is a strip of wires, whether it could be 8, 16, 32, 64. Okay, so it is a strip of wires. And this, I already told you what is the use of a bus. Bus carries information from place to place inside the computer. So bus is of three types. One is address bus, data bus, and control bus. And among these three, the third one, which is not introduced here, is will also play a key role. So this control bus will tell what type of action or what type of operation the CPU want to perform on the devices. These both I/O and memory. Okay, so it could be either read or write. Okay, so if you want to read from the device, it will be given, the information will be given with the help of control bus. If you want to write into that particular memory location, that information will be given with the help of a control bus. So there are three buses to summarize: address bus, control bus, and data bus. Address bus is the bus which will help us to identify the device. Addresses are unique, and data bus is just like a transportation system in the real world. It will be helping us to move the data from one place to other place. And coming to the control bus will be helping us to know what is the status or what the CPU want to do. Okay. So this address bus and data bus will determine the capability of a given CPU. If you want to decide what is the capability of a given CPU, so the CPU indicates what here, whether it is 8051 or 8086 or latest microprocessor in the market. So if you want to know the capability of such a CPU, then this address bus and data bus will be helping us to determine the capability of a given CPU. Now coming to the more information about data bus, then we will go with address bus and we will go with control bus in the coming sessions. So now we will first discuss about data bus. What is data bus? So data bus, as I already told you, it is a group of data lines. The group of data lines which are available to carry or to move the data from one place to other place is called as it is actually a data bus group of data lines. Say for example, I want to move 8-bit data, so I need 8 wires. I told you just now, right? Strip of wires is called as a bus. So here we are discussing about a data bus. So data bus will be typically in the range from 8 to 64. The data lines will be from 8 to 64. In olden days, the first computer also used 8-bit data bus, and at the same time the supercomputer also used 64 KB data lines. So typically the data lines could be 8 to 64. So what is the processing power is related to this data bus. Not only data bus, also the address bus. So I will tell you what exactly mean by this processing power is related to size of the data bus or size of the address bus in next few minutes. Now coming to the this data bus and bidirectionality. So what do you mean by bidirectionality? Data bus is a bidirectional bus. So the data bus, whatever we have here, it is bidirectional. So depending upon the type of device, whether you are using RAM or ROM, these directions will be decided. That's why I didn't draw the directions here. So data bus is bidirectional bus. It is a bidirectional. So here if I write directly like this bidirectionality, it may not hold with this device RAM. Sorry, this device ROM, because ROM is only read-only memory. We cannot write into that. So bidirectionality I should not draw it here. But to tell you that data bus is bidirectional, so I have indicated bidirectionality for both devices. Now coming to the address bus. Address bus is unidirectional. It is only in one direction. From the CPU, it will go towards the devices. Okay. So if you look at this address bus, it is unidirectional. From the CPU towards the devices. So just now I told you, right, the device needs to be recognized by the CPU with the help of the address that is available on the address bus. So CPU will put some address into the address bus, and based on the address we will identify what type of device it want to read or write from. So that address bus is a unidirectional, and one more important feature of this address bus is the number of address lines will decide the memory handling capability of that particular CPU. So that's why I told you the processing power is related to the size of data bus and address bus. So not only the data bus, actually the data bus size is fixed. It is 8 or 16 or 32 or 64. Okay. But whereas the address buses are available in 16, it starts from 16, it is available in 20, then it is available in 32 and then 64. These are the typical sizes of the address lines. So depending upon the number of address lines which are available, the memory handling capability or the addressing capability of that particular device, both memory and IO addressing capability of that particular CPU will be decided by the formula 2 to the power of n. N is number of address lines. N indicates number of address lines. Okay. So if there are 16 address lines, then it will be 64 KB. 2 to the power of 16 is equal to 64 KB is the maximum memory it can read. 64K IO locations it can access. If it is 20, 1 MB memory, similarly the respective address lines. So 2 to the power of n is the formula to decide the number of addressing capability, either IO or memory. So that is about the address bus. Address bus, to summarize, address bus is unidirectional and data bus is bidirectional. And data bus typical sizes are 8, 16, 32 and 64. Okay. So coming to the control bus. Control bus, you can see in this diagram, in this internal organization of computers, this diagram is same like this. But what is the change here is that RAM and ROM are mentioned separately here, and IO peripherals also mentioned separately here. And the three buses are available here. You can see the red color one is the address bus, which is only unidirectional. It is connected to RAM, ROM, printer, disk, monitor and keyboard. Okay, so there is no change in the arrows. All the arrows are coming from CPU towards the devices. But whereas this data bus, you can see the data bus, which is black in color here, is in bidirectional with RAM, only in one direction with ROM, because ROM, if we cannot write, we can only read from the ROM memories. So CPU is just reading from the ROM memories. It is not writing into the ROM memories. Similarly here printer, okay, only writing, and here disk, both read and write bidirectional. Monitor only writing, unidirectional. Keyboard only reading, unidirectional. So even though the data bus is bidirectional, it can carry both data in to and fro, but the direction will be decided by the type of device with which it is connected. So that point you have to note. And coming to the one which we are discussing about, the control bus. So in this case here, control lines mentioned are read and write. Okay. So typically the control lines would be 2 or 4 or even more than that. So here I mentioned read write. So here you can see memory read, memory write. Okay, and it is only read because ROM is only read. And here it is IO write. Similarly disk, monitor and keyboard. So the control bus will provide the information about what the data the CPU has to either read or write from the devices. So to summarize, we have discussed about inside the computer and internal organization of computers. So the architecture of every processor or controller is divided into 3 parts. One is CPU, memory and IO. And we have learned about how these 3 devices are connected with the help of address bus, data bus and control bus. The typical size of the address bus are typical sizes are 16, 20, 32, 64, and the formula to calculate the number of address space, whether it is memory handling capability or IO addressing capability, is given by 2 to the power of n, where n indicates number of address lines. Data bus, which is bidirectional, its typical lines are 8, 16, 32, 64, and control bus is also bidirectional. Here I forgot to mention that control bus is also bidirectional, and the bidirectionality will be decided by again the type of device or the type of operation with which the CPU and the device want to have. So that is about the summary what we learned so far. So if you have any doubts, feel free to put it in the comment section below. Then in the next video we will start a topic which is in connection to this diagram. We will again go into the details of how a CPU reads information from the different devices with the help of buses. So until then, thank you. If you like the video, subscribe, share it and send it to the maximum audience who are in connection with this particular topic. Thank you.